So here I'm going to use R, and particularly the dnorm function, to compare a t distribution. Like we know, from theory that the t distribution is, fatter tails and a kind of a fatter top than the normal distribution. But we're going to be able to plot it using R, and the way I do it is pretty. It's kind of straightforward, but it uses some tools I've learned. The one thing is that to remember is degrees of freedom increase, the t-distribution approaches the normal distribution. So I set the degrees of freedom as 2 here, simply to make it really look different from the normal distribution, but that's really small degrees of freedom. Okay, and then I wrote some code where I'm going to plot along an x-axis, and then we're going to visualize those two graphs together. Okay, so I set my degrees of freedom, and what I do here is I actually set a range from -10 to 10 with steps of 0.1, and so this is going to be a range that goes the whole length. All right, so I'll kind of start there as I talk. You can see it goes from 10, 9 point x-axis for a distribution. Then what I'm going to do is I'm going to take the length and make a sequence of zeros for D2 and D3, and then I'm going to fill those in as I calculate. So I'm going to start with two sets of zeros, and then I have a loop where I am going to go from the length of D2, which again is this sequence here, it's 201 long, and I am going to fill in each observation of D2 and D3 with the density at that number, right? So it's going to start low and then it's going to go high. And I do that for the normal distribution for 2 and the t-distribution for 3 with the degrees of freedom I chose. Now I could change that, but I get a real drastic difference here. But here the degrees of freedom are chosen, and then it gets plugged in here. All right. So when I do that, you'll notice that my all zeros here become the numbers. So they start really, really low, but you can see that t is a little bit fatter, right? You can actually see the number, but that the normal, this value is so extremely low. Here it's just really low, right? So you can see the fatter tail here, all right? And we can look at D2 and you can see the numbers that go in here, all right? Now we're going to plot the density curves on top of each other. So we've got our x-axis, which is the sequence we built. Then we've got D2, which is normal. I know this goes from -10 to 10, but we're going to really limit it to 4 and 4 because it's so low. All right, and then we have our y-lim, which is what I pre-planned, because we don't want, first of all, we don't want the two axes to be different because R will overlay them. But we also want to make sure it's visual, all right? So it matches what we see. So this is chosen because of that. But it's the same for both. No x-axis label, and then y is just probability, and then the green, it's going to be red, a red line for the t. Right. So what we see here is the two are going to be superimposed. Legend. All right, we've got the T and the normal T, right, standard. It's going to be in the top right. We have our legend pasted, and then we've got our two lines and our two colors, and at the final code is no box. All right, so when we do it, it's pretty straightforward. We first start not normal, and then we've got our T in red, right? We just plotted it over. We can see the fatter tails and the flatter top. Put our legend in. Black and our T with 2 degrees of freedom, right? So we're able to, again, like I've been doing, do two things at once, right? We're practicing stats, but we're also practicing R, right? So we actually did some visualization tools, right? So this is not randomly generated data like I did for the F. This is theoretical data because I went every point and calculated the actual density at that point. So I started with a range and then I calculated it and got a smooth curve. And I did that for both the normal and the T, right? And we can actually see how, 2 degrees of freedom, 2 standard deviations either direction, you get into the 5% zone, but you can see because of the fatter tail that the T number, the critical value, is going to be slightly larger, right? You can plug those in as well. We know 1.96. One thing to think about is what is the critical value at different from 2. All right. All right, and then finally we have. All right, we were able to plot it. We were able to make a nice legend. So that's what we do. We practice the stats, and we're comparing normal and T, which is something we know theoretically. We're able to use R to calculate a range, make a smooth curve, and then differentiate the colors and make a legend.